Hello everyone, it's Mrs Edwards here, and this is your maths video for Wednesday the 19th of May 2021. So today we are going to continue our learning relating to shape, and this week we are investigating different properties. Now, what did we do yesterday? Can you remember? Yesterday we investigated irregular 2D shapes, so I'm going to ask you to pause your video for a moment. Can you describe, can you explain what irregular 2D shapes these are? Hello and welcome back. Yes, well done if you realised that all you needed to do was count the sides. And our first one here, our purple one, is an irregular pentagon. Of course, it's irregular because the sides are different lengths, whereas a regular pentagon has sides that are the same length. And if you recognise that our pink shape here is an irregular hexagon because it's got 6 sides. And then well done if you recognise that the red shape here is an irregular octagon because it's got 8 sides. So all this week, these are the vocabulary words we are using to describe our shapes. And today we are investigating what 2D shapes can be found on 3D shapes. So here is my example. If a cube is unfolded, it would look like this. What 2D shapes make up the faces? And I'm sure you can see that there are 6 squares, which means that the faces are made up of 6 squares. And this information can be used when describing a 3D shape. So, some faces, however, can't have faces that are identified as 2D shapes, but this information can also be used to describe the shape. So, how could we describe these shapes? Well, if you look at the top one, it is a sphere, but there is no identifiable 2D shapes on it. So when describing it, I could say my shape has no identifiable 2D faces. And then if we look lower down, this is a cone, and I can describe the bottom one as a circle, but I can't describe the top one as anything. So if I was describing this one, I would say my shape has one 2D face that is a circle and another face that is unidentifiable as a 2D shape. So today you're going to use the information you can find on 3D shapes to describe them. And your first challenge today is this one. Can you correctly identify the 2D shapes on these numbers, and then could you match them to the 3D shape below? So if I built these shapes, which one of these would it become? That's your first challenge for today. Your second challenge for today is identifying these 2D faces on these 3D shapes. And there's a collection of them there. I'm not asking for the names of the shapes, I am asking for what 2D shapes you can see. And remember, if you can't identify a 2D shape as a face, you just write no 2D shape. Just a little bit of a clue there. Your third challenge today is, without cheating, can you name the 2D shapes that would be found on these 3D shapes from memory? So without having a sneaky Google to look what these shapes are, can you use your memory? Can you name the 2D shapes on them, please? There's 1 or 2 little tricky ones in there. I'm sure you can work the answers out. And then if you get that far and you've still got time, what patterns, what similarities, what differences have you found in your findings today? What have you noticed about the 2D shapes that can be seen on the 3D shapes? Okay, so that is your learning for today, lovelies. I hope you get on all right with your maths work. Please remember to upload it to Dojo or to our class email or indeed Teams, and I look forward to seeing it later. Thank you. Bye bye.